Hi folks, we're going to take a look at number 16 from page 554. So they give us this system of equations, but we see that there's an unknown d value on the other side of one of the equations. Okay, they want us to find this k value such that the solution to this equation is going to be equal to a line. Okay, and then they want us to find the vector equation of that line. So let's recall that first of all, let's take a look. Are there any parallel planes? And I look first and second. No. First and third, definitely not. And second and third, so no parallel planes. Okay, so that means the only way that this can have a line is if you've got your sort of star scenario where, again, the plane's coming out of the page and they intersect in this line. Okay, now what's that going to look like when we try to solve the equation? So since we're going to have infinitely many solutions, we know at some point we should come out to something that looks like 0 equals 0. Okay? Or if we solve it via matrices, we should end up with a row of zeros, which indicates exactly that. Okay, so what I'm going to do is I'm going to solve this and see if I can figure out what k needs to be in order to have a row of zeros. Okay, so let's start by creating our matrix. So 1, 1, negative 1, 1. Okay, here 2, negative 5, 1, negative 1, and 7, negative 7, negative 1, and k. Okay, so now I'm just going to proceed as I normally would. Let's start by by eliminating these first terms in the rows. So here we have negative 2r1 plus r2 replacing r2, and negative 7r1 plus r3 is going to replace r3. Okay, so first row doesn't change. Okay, so here what do we have? We have negative 2 plus 2, 0. Negative 2 minus 5, negative 7. Here we have 2 plus 1 is 3. And here we have negative 2 minus 1 is negative 3. Okay, so let's do the third row now. So negative 7 plus 7 is 0. Here we have negative 7 minus 7 is negative 14. Okay, and here we have 7 minus 1 is 6, and here we have negative 7 minus k, or sorry, plus k, so negative 7 plus k, and there's our last component. And we notice here, by looking at the left-hand side of my matrix, that these are indeed scalar multiples of each other. Okay, so in other words, R3 is just 2 times R2. So if I need to get a row of zeros here, I need negative 7 plus k to also be twice negative 3. Okay, if I needed it to be have no solution, that could be anything other than that scenario. So here I need negative 7 plus k to also have the same scalar factor. So this needs to be equal to 2 times negative 3. Okay, and then we can solve that. K is equal to, so negative 6 plus 7 is just going to be 1. So this is the k value needed in order to have a solution that's a line. Okay, so now they want us to find the equation of that line. Well, we know that once we get our row of zeros, we're just going to be working with these two rows because it's like finding the intersections of two planes. So from row 2, I can write that negative 7y plus 3z is equal to negative 3, and I can solve y in terms of z or z in terms of y, and then do the same thing for the x. Here, I think it's easier to solve for z, so I'll at least have one less fraction. So we have 3z is equal to 7y minus 3, so z is equal to 7 over 3y minus 1. Okay? And now I take that other equation to write x in terms of y. Okay, so here we have x plus y minus z, but of course z now we know we wrote as 7/3 y minus 1, and then equal to 1. Okay, so let's solve this here. So we have x plus, I'll put this over 3, so 3 over 3y minus 7 over 3y minus 1. Oh, sorry, that's going to be plus 1. Almost forgot that negative there. Try to be careful. So here, what do we have? X is equal to, so 3 minus 7 is negative 4. So bring that to the other side. It's going to become positive 4/3 y. And here, 1 minus 1 is 0. So that's it. And now we can write the equation of our line by setting y as the parameter. So we'll say let y equals t. So the equation is just x is equal to 4/3 t, y is equal to t, and z is equal to 7/3 t minus 1. And of course t takes on all real values. Okay, so notice here two things was I solved this exactly the way I would have solved any other system of equations. First, check if there's any parallel planes, then put it in a matrix and try to reduce that matrix. But because I knew the solution had to be a line, I know I had to come to a row of zeros. In other words, I had to get one row that was exactly the same or a scalar multiple of another row. And that's how we were able to determine the k value. And then the rest was just what we've always done. Okay, that's it for this one.